Welcome to the Skill Builder session with Dr. Ghassabian and Dr. Trasande on exposure to endocrine disputing chemicals, considerations for maternal and child health. My name is Onyekachukwu Anakamadu, and I am a second year MPH student at St. Louis University College for Public Health and Social Justice, and I am an intern with City Match. I will be the moderator this morning for this session. And before the presentations begin, I would love to give some quick background information on both Dr. Ghassabian and Dr. Trasande. So Dr. Ghassabian is a medical doctor from Tehran University of Medicine and has an MPH and a PhD holder from Erasmus University, Rotterdam from Netherlands. And she is also an assistant professor at NYU School of Medicine and an investigator at the NYU Center for the Investigations of Environmental Hazards. Her research includes identifying environmental exposures that contribute to the etiology of developmental disabilities and psychopathology in childhood. Her work in observational epidemiological studies has revealed that maternal thyroid mild hormone insufficiency has a negative impact on various aspects of children's cognitive and behavioral development. And she has an investigated role of autoimmunity, iodine deficiency, and environmental toxins as underlying factors. And Dr. Trasande is a professor and vice chair of pediatrics, where he directs the NYU Center for the Investigation of Environmental Hazards. His research focuses on identifying the role of environmental exposures to childhood obesity and cardiovascular risks. He has published a book titled Thicker, Fatter, Poorer: The Urgent Threat of Hormone Disputing Chemicals to Our Health and Future, and What We Can Do About It, highlighting how these toxins affect our daily lives and the steps we can take to protect ourselves and fight back. So although I could go on and on about the accomplishments these two doctors have done throughout their careers, you can always go to the conference platform to read more about them or discuss with them on your own time. If you have any questions during the presentation, please enter them in the chat below at the bottom of the screen. We will have some time for question and answers at the end of the presentation. So without further ado, please allow me to introduce you to Dr. Ghassabian and Dr. Trasande.
Good morning, and thanks for the opportunity. I'll kick us off with just a big picture outline and then begin with the first presentation. Akhgar will follow with the second, and I'll come in with a closing set of remarks that focus more on the policy aspects that are terribly important. Go to the next slide. So there's a lot of new knowledge that we'll describe, and this is such a hot and emerging topic that quite literally, as one publishes a paper, immediately in the space there are other papers that are coming along that are shaping and changing and unfortunately revealing more effects of synthetic chemicals in the environment and how they hack our natural signaling molecules, our hormones in our bodies. We're going to focus particularly on effects on brain development, and Akhgar will lead that part of the discussion, and then I'll come back to those policy implications and safe and simple steps we can take at the individual level to prevent exposure. So we'll go to the next slide, and I'll just mention that we collectively have a variety of funding from federal entities, but as was mentioned at the top, I have written a book and therefore have received honoraria from publishing companies relating to the book published in a couple of different languages. So that can be considered a potential conflict as you wish. And I've also advised companies that are trying to do the right thing in this space in particular. So let's kick off with some new knowledge of health effects. So I'm just going to go back to when I was a medical student in the 1990s. And when I was coming through, I have to say, I was not made aware of endocrine disrupting chemicals. In fact, I was told through toxicology classes that only the dose makes the thing a poison. It's a saying from Paracelsus. You've probably heard it from the 1500s. He's a Swiss philosopher and scientist who identified this phrase, recognizing that it's akin to everything in moderation, if you will, that a little bit of something isn't as bad as a lot of something. And generally that proved to be true. After all, we've had this notion for 500 years. But the theme of this discussion is that our basic paradigm is not always right, and in particular, it's increasingly understood not to be correct, particularly when it comes to hormones in our bodies. And the consequences in humans of these disruptions really emerged in the wake of Silent Spring. Rachel Carson's wonderful description of the effects of DDT on wildlife. That pesticide was later found to have a variety of effects, not just in the first generation of exposed humans, that is the children of the mothers who were exposed. This pesticide was widely used in agriculture and across the urban and rural environment, but we're now even finding effects in the grandchildren and great-grandchildren of those mothers who are exposed, independent of the exposure in the subsequent generations. And on the right, you may not know this, but there was another pharmaceutical that was starting to get used in the 1950s and 1960s called diethylstilbestrol. It's a synthetic estrogen that was intended to prevent miscarriage and other unwanted consequences of pregnancy. And it was an astute clinician at the Massachusetts General Hospital who identified a rare cancer in young girls that was directly related, and he subsequently published these findings in the New England Journal of Medicine. A theme cutting across DDT and diethylstilbestrol is that they're both banned chemicals. And we did the right thing. We banned DDT except for certain uses in sub-Saharan Africa for malaria prevention. And even that is phasing out as we've developed a vaccine, and there are other initiatives underway. And the same for diethylstilbestrol, was quickly banned in the 1970s. But as we move to the next slide, we thought we were okay, and maybe we thought wrong, unfortunately, is the theme of this presentation. We now know of over 1,000 synthetic chemicals that can disrupt hormonal functions and thereby contribute to disease and disability. To some extent, our own sense of safety was driven by our lack of understanding of basic mechanisms in the human body. So we've had the Human Genome Project in the 1990s and early 2000s that helped us understand gene mutations and polymorphisms and their effect on disease and disability. But as we unravel the human genome, we realized that there are other aspects of genes, in fact, tags, without changing the genomic code, through the science of epigenetics, methyl tags or other types of tags that are put on the ACGT code without mutating the genes, that can thereby affect a variety of biological functions. And in particular, the chemicals we're talking about are increasingly understood not necessarily to disrupt hormonal function by affecting how receptors get bound in the human body, but by changing how genes are expressed. And the more we dig, as you see on the right, the more we realize that these exposures that are known to affect human health by disrupting hormones in our bodies are part of our everyday life. We're talking chiefly about 5 categories of chemicals: non-stick chemicals called perfluoroalkyl substances used in oil and water resistant clothing and food packaging; phthalates used in personal care products, cosmetics, and food packaging; bisphenols used in aluminum can linings and thermal paper receipts; pesticides used in agriculture; and flame retardants used in electronics and furniture. And the more we unravel the endocrine system and understand it, the more we realize that it's not just sex hormone, thyroid hormone. There are many signaling molecules in the body with complex relationships that practically involve every organ system under play. So what I'm going to describe is emerging. It's rapidly being unraveled, but is we don't know everything about these effects either. We only know the effects of 1,000 known knowns, if you will. There's so many chemicals that have not been tested for their safety when it comes to the hormone system in humans. We can go to the next slide at this point. As I've alluded to, this Swiss gentleman by the name of Paracelsus, or Theophrastus Bombastus von Hohenheim, had this adage that still works in certain ways for certain chemicals in certain contexts, but we also appreciate there's complexity in the effects of these exposures. Timing matters, so vulnerable windows of development, like Dr. Ghassabian is going to describe, have consequences. We realize that we don't live in a single exposure environment. We're exposed to thousands of chemicals that are synthetic and widely dispersed in the environment through a variety of products. We've already talked about epigenetics, and as you can see on the right, there are biological studies, now 500 or so, or 600 as you can see on the slide, that describe unusual relationships such that you can't extrapolate from high dose experiments in animals to assess what the safe level is in humans. And that's because there are steeper than linear relationships that can occur at the lowest levels of exposure. This is even true, by the way, for lead exposure now, the way we understand it. In addition, we know that there are so-called U-shape, or what I call roller coaster ride relationships between exposure and effect, that mean that we can't extrapolate from high dose exposures to low dose exposures, because in fact the effects at the lowest levels of exposure may drop before they come back up again, such that you can't really make the extrapolation from a series of serially dosed experiments to decide what is the no observable adverse effect level, which is what the Environmental Protection Agency uses for many chemicals. So we can go to the next slide. So as I talk about this, you may be saying, well, why hasn't this come on the scene? And the fact is that this is a very new issue. The Endocrine Society, a society of 14,000 endocrinologists, scientists, clinicians, etc., wrote their first statement documenting the effects of chemicals, particularly in animals and in the laboratory. Not long thereafter, the World Health Organization and United Nations Environment Program put a major report on the map documenting this as a global public health threat. That was in 2012. We can go to the next slide. There was a lot of debate about these reports, and in fact the international entity dealing with chemicals at the UN, called the Strategic Alliance for International Chemicals Management, affirmed this report, noting in particular that chemical and pesticide industries were the only ones who had concerns about the state of the science. So it tells you how strong this science really is. And I want to emphasize that, you know, in the era where there's a lot of concern about transparency in science, this science has been heavily debated in public fora through usual peer review processes documenting these effects. And what you see on the right is the Endocrine Society saw so much science develop in the 6 years after its first report, 1,331 scientific references, that it felt the urgent need to put a second report in the peer-reviewed literature documenting particularly the effects on human health in this report. So really this science is snowballing faster than you can imagine, unfortunately. Moving along to the next slide, other large medical and scientific consensuses have also emerged. So the International Federation of Gynecologists and Obstetricians has put together guidance for patients on the lower left. The American Academy of Pediatrics has put particular emphasis on chemicals intentionally and unintentionally added to foods. I had the privilege of supporting that effort in 2018. And in the obesity community, policies that prevent these exposures have been emphasized as a high priority item by the International Obesity Task Force. So we're talking about broad mainstream recognition of this issue as it has emerged over the past few years. We can go to the next slide. I apologize for the helicopter background, by the way. Now, the mechanisms by which these chemicals can contribute to disease are not just purely through hormonal disruption. Early life is particularly a vulnerable window, and that's because when you restrict fetal growth, we know that fetal growth restriction can contribute to a thrifty phenotype, thereby contributing to not just childhood obesity, but adult obesity and cardiovascular risk. The late Sir David Barker first described this notion for larger scale nutritional deprivation, but we increasingly recognize that environmental and low level exposures can have the same untoward effects. We can go to the next slide. Just to talk about obesity for a moment and insulin resistance, we know that there are a host of chemicals that can contribute to childhood obesity. The first prototype, you could say, was prenatal cigarette smoke exposure, which in a meta-analysis of dozens of studies has been associated with increased risk of obesity. In the laboratory, we know that a chemical that was used on the hulls of ships for many years called tributyl tin, it's a contaminant in certain plastics, has been associated with obesity, not just in the first generation of exposed laboratory animals, but 3 generations down the line. So with the science of epigenetics, we appreciate that epigenetic marks can be transmitted beyond the child to the grandchild or great-grandchild by epigenetic mechanisms in the absence of exposure in subsequent generations. And you can see on this list a couple of the chemical categories which I emphasize: BPA used in aluminum can linings and thermal paper receipts, the brominated flame retardants, just to name a few, as well as the PFAS. Next slide. So just to dwell a little bit on bisphenols and phthalates first. So bisphenols can have all the molecular hallmarks of obesogens, chemicals that literally make us fatter. They're one of a group of 50 or so chemical compounds that we know that contribute to obesity. BPA makes fat cells bigger, disrupts a protein that protects the heart called adiponectin, and can have sex-specific effects on body mass by being a synthetic estrogen. For what it's worth, as a historical aside, it was considered as a synthetic estrogen in pregnant women when DES was introduced, but it wasn't potent enough, which is a bit of historical irony. We know that these chemicals are increasingly being replaced as attention has come out, and we have BPA-free baby bottles and sippy cups. We have now 40 or so what we call artists, formerly known as BPA. One of those, bisphenol S, is as estrogenic and as toxic to embryos. So in many ways, once we identify a chemical of concern, often what we're seeing is emergence of newer chemical replacements, and we're literally whacking the mole, which is the theme of this presentation. Next slide. Phthalates, on the other hand, induce obesity through a couple of different ways. One is some of them, the low molecular weight phthalates used in personal care products and cosmetics, antagonize the male sex hormone, testosterone, and the higher molecular weight phthalates can also particularly have effects on the expression of genes that are crucial in lipid and carbohydrate metabolism. So you can imagine you're having a healthy protein meal, you've had a good exercise, and you think you're going to be making muscle. Unfortunately, these chemicals literally divert the caloric processing such that it turns into more likely fat as opposed to muscle. I'm going to the next slide. We've studied these chemicals in a large Dutch cohort called Generation R. It's a prospective birth cohort where we were able to examine effects in over 1,000 mothers and their children, looking at fetal as well as postnatal growth, as well as fat mass, insulin resistance, and blood pressure. I'm going to quickly run through these findings, and I'm happy to go over more specifics offline, but just to give you a flavor of the effects that we're talking about. We can go to the next slide. So what we're seeing here are effects on fetal growth. That Barker hypothesis looms large here. And what we found are that phthalate exposures reduced fetal weight all the way through birth, with particular effects later in gestation, where the majority of fetal growth occurs. What we also found is that certain phthalates reduced gestational length, increasing risk for preterm birth, which is remarkable in this cohort because the incidence of preterm birth is so low. It's relatively well birth cohort. We also saw that certain phthalates were associated with small for gestational age, a comment that Akhgar will build upon, thinking about effects on brain development. Bisphenols in this study were not associated with fetal growth, especially after control for some of the repeated tests that we had to do on the data. And go to the next slide. Now, from a postnatal growth perspective, you might see what I'm about to describe as confusing, because we did not see the Barker hypothesis show up at least at ages 6 and 10 without associations of phthalate exposure with body mass. What we did see, which was quite disturbing, you might be confused by the lower body mass index in the children exposed to bisphenols, but when you look deeper at the data, the pattern was partly explained by decreases in bone mineral density, which has huge consequences for bone health in these exposed children, for osteoporosis and such. But the biology here is because bisphenols divert how mesenchymal cells, stem cells in our bodies that are intermediates, they can become muscle or bone or fat. And in the laboratory, we know that bisphenols divert the fate of these stem cells towards fat and away from bone. And thereby, you can imagine these effects are also occurring in humans, as we're seeing here. So that consistency is rather remarkable, and we're following that up as the cohort ages over time. Go to the next slide. When we looked further at the phthalates and their effects, you'll recall that we did not see increases in body mass, but when we looked deeper at more specific end organ effects, we found some very disturbing patterns which really do support the Barker hypothesis. We saw an increase in fat around the heart, and that fat around the heart is a problematic sign, particularly for later heart disease, at least in adults, but also in younger adolescent children. And we also saw some adverse metabolic profiles, increases in blood pressure and triglycerides, particularly in certain sexes. Now, there were some effects in the other direction, which suggests some complex mechanisms that we need to unravel better as we understand this. This is only an association study, not a mechanistic study. Go to the next slide. Now, this is a pediatric audience, maternal child health audience, but just as an aside, I do want to emphasize the effects in adults are real of these chemicals too. Life is a vulnerable window of susceptibility to these chemicals. We've seen increases in thickness of the blood vessels that feed the brain, the carotid artery, as well as increases in coronary artery disease, decreases in heart rate variability, a marker of heart disease, and frankly, mortality due to cardiovascular disease association with BPA. We can go to the next slide. I already mentioned that certain phthalates reduce testosterone function. So the implication of low T, it's either a marker for a predictor of adult cardiovascular disease in men. The implication here of these phthalates affecting cardiovascular mortality is borne out by the fact that we've seen in cross-sectional studies decreases in testosterone in adult men in association with exposure. When you extrapolate that, as we'll describe in the next slide, we're talking about potentially tens of thousands of adult men dying earlier from cardiovascular disease. At least that's based on the data linking testosterone levels to cardiovascular mortality in men. But moving along to the next slide, ever so briefly, phthalates have actually been very recently directly related to all-cause mortality, and particular cardiovascular mortality. Now this time we found it in men as well as women, which suggests it may be through inflammation in the blood vessels, which phthalates and bisphenols unfortunately do through what we call oxidative stress. And that may be the mechanism, which suggests actually a bigger impact at a social level, potentially with 100,000 adult deaths each year and $40 billion or so in lost economic productivity, because these are adults dying in peak earning years. We can go to the next slide. Just to dwell for a moment about the perfluoroalkyl substances, or PFAS, if you want to learn more and are curious, the story of PFAS is best told in a Mark Ruffalo documentary called Dark Waters on the right, of which I'm a big fan. But the reason I'm talking about these chemicals is that these carbon-fluorine bonds, these chains of carbon-fluorine bonds that are quite strong because they're so polar, make their use in nonstick and oil and water resistant clothing particularly useful because that provides a resistant layer for other things to come in. And other molecules literally bounce off these non-stick chemicals, and that's why they've come into use so widely. The dark water story is really about a large-scale water contamination in West Virginia. We can go to the next slide. But we realize now that low-level exposures are equally important, like things you see in food packaging or through daily contact of the skin with oil and water-resistant clothing or use of nonstick cooking materials. We've seen decreases in birth weight that are consistent across multiple studies, as well as increases in body mass index Z-score, which is reflective of the Barker hypothesis. We've also, in the next slide, have described effects on adult weight gain and incident diabetes, suggesting again that adults are also vulnerable to these effects. We can go to the next slide briefly. Fertility is also an endpoint that can be adversely affected. This is best described for male factor infertility because phthalates have been associated with reductions in an anatomical distance called the anogenital distance. And anogenital distance persists in a pattern consistent and is preserved from the child period all the way to adulthood, and adult AGD has been associated with infertility as well as adult cardiovascular disease. And unfortunately, we now realize that the phthalates have been associated with shortened AGD at birth, and other studies have suggested a host of other EDCs in association with reduced fertility and decreases in semen quality. But I have only given some of the weaker associations, even though they're quite strong, and Akhgar is going to dwell in particular on the effects of EDCs on brain development. So with that, I'm going to pass the baton.
Thank you, Leo. Thank you so much for this introduction. It was a very great overview of what we know about EDCs, especially in relation to obesity and cardiometabolic health. And now I'm going to switch the gear to brain, and now I will go deep into some potential mechanisms for the potential effect of EDC on child brain. So similar to Leo, I have funding from different institutions to do research on effect of environmental chemicals on human health, particularly children. I go back to the Dohat hypothesis, as Leo described as Barker's hypothesis, developmental origin of human health and diseases. In that hypothesis, we argue that exposure in sensitive periods of development can have really long-term consequences for human health. And brain is not really spared from that argument because of the several processes that happen during the prenatal period, early embryonic period, and later on, and then early childhood, from neurogenesis, neuromigration, and later on the global development of the brain. So two groups of chemicals are really widely studied in relation to their brain influences. One is the promenaded flame retardants that are currently banned in the US and not really used anywhere, but because these are persistent chemicals, we still have high exposures in human population around the world. PBDs are usually were added to as flame retardants to several products. It was obligatory in the US, not in the EU, but now they're not using anymore. The fact that they are in the environment for a long time allowed several cohorts to look at their influences on child neurodevelopment. 3 US studies looked at the longitudinal association between prenatal exposure to PBDs and child IQ in the United States, one in the home cohort in Cincinnati, one California cohort, and one in New York City. And they all found consistently that there was a dose-response relationship between exposure to these chemicals in mothers during pregnancy and lower IQ in children. The other cohort that looked at the association in Europe, that was interesting that they could not find as convincingly as the US cohort, probably because exposure levels are substantially lower in the US and the study was much smaller. Another group of chemicals that's also widely studied in relation to child neurodevelopment are organophosphate pesticides. Several of them are non-persistent, so it's very tricky to measure those exposures in individuals, but we have really come to a point at today that by measuring these non-persistent chemicals with short half-life repeated in individuals, we can really get a good picture of individual exposure. So particularly one cohort in New York City looked at exposure to one of these chemicals, chlorpyrifos, that is also was used for a long time in the household in New York City, and is still in use in for agricultural purposes. They looked at the exposure, prenatal exposure. So they went and really measured chlorpyrifos in cord blood to get a measure of fetal exposure, and they found that it was related to lower IQ in children. And this study was one of the first that they also took it to another level. They looked at brain development. So they brought these children, about 40 of them, back to the center. They scanned their brain using MRI, and they looked at brain surface and thicknesses in various cortices, and they found that the exposure to organophosphate pesticides associated with thinner cortices in frontal-parietal cortices. So that was a very important finding back then, because it was one of the very first evidence that these chemicals really influence brain, and that's why we see eventually the effect on child IQ. Very recent study from the Generation R cohort, as Leo talked about that cohort in the Netherlands, did the same analysis in a much larger sample, this time in more than 500. And they also looked at another aspect of brain development, which is the connectivity. So how different brain, part of the brain are connected with each other, which we know that is important for not just IQ, but also for behavioral outcome. And they found that if you measure the metabolites of these chemicals, organophosphate pesticides, in pregnant women during pregnancy, we see associations with indicators of the better connectivity. So here you see the upper two rows are the connectivity between brain parts. The measure is fractional anisotropy, or FA. So higher FA, better connectivity, and the lower ones are mean diffusivity. So the higher means worse connectivity. And very consistently, they found that a higher exposure to organophosphate pesticides are related to worse connectivity between brain regions. So what are the potential mechanisms? We looked at the brain and we found that the traces are observable in the brain, but what happens from these chemicals to the brain of the child that eventually leads to lower IQ or more problem in behavior or other child outcome? So something that I want to talk about today is thyroid and the role of thyroid hormones, and of course, disruption in brain development is not a new topic in medicine. So we know for more than a century that insufficient iodine intake and related to that insufficient thyroid hormone production is related to impaired physical and mental development. So because of all the efforts around the world to combat the iodine insufficiency around the world, we do not see a lot of that condition today, also because many countries around the world, they have the neonatal screening for hypothyroidism, and that's why we are really battling the outcome of physical and mental impaired development. But that's not the, I will show you in a few slides that that's not the whole picture of that, the severe hypothyroidism related to low iodine intake. So maybe not really new to this audience, but just a reminder for all of us about the thyroid axis. The production of thyroid releasing hormone from the hypothalamus influences pituitary to produce a thyroid stimulating hormone, and then thyroid glands produces thyroid hormones that target several organs in the body at different stages of life. It starts from the gestation and continues through adulthood. And brain is one of the targets for thyroid hormone. So the whole system is in a very tight regulation to keep the thyroid hormones within a very narrow range for optimal growth and development. But I'll tell you in a few slides why pregnancy might be an exception to this rule of tight regulation, and what might go wrong during pregnancy that might lead to poor outcome in the offspring. So what happens in pregnancy is that a lot of brain processes like neurogenesis, neuronal migration in early gestation and later on the synapse formation, myelination, they respond to thyroid hormones. But we know from several studies in animals and then later on also established in humans that the thyroid gland is not really fully functional until birth in fetus. So the fetus really relies on maternal sources of thyroid hormones, and in the first 14 weeks of gestation, that is the entire source of thyroid hormone for the fetus. That's it's interesting also to mention that the receptors for thyroid hormones in the brain, in the fetal brain, is already present at week 7 of gestation, meaning that thyroid hormones from maternal sources are important for brain development of the fetus as early as week 7. But in pregnancy, because of the high demand in pregnant women, because it's not that they only need thyroid hormones for their own optimal function, but they also need thyroid hormones for the optimal development of the fetus. Because of that high demand, we might have insufficiency in moms. One condition is overt hypothyroidism, of course, that we have high levels of TSH that is detected in screening, and then low free T4. And of course, the patient is symptomatic. This is, if detected, should be treated according to the guidelines and recommendation for a long time. We know that more than 50 years now. The other condition is maternal subclinical hypothyroidism. So basically, she might not have the symptoms of low thyroid function, but she still has high TSH level in screening. And recent guidelines in the past 5 or 6 years recommend treatment of subclinical hypothyroidism in pregnant women if detected based on screening or other reasons, and because of the potential impact on on the offspring neurodevelopment. But the third condition might not be very known for in general, because it's very specific to the pregnancy period and pregnant population, and that's when the thyroid hormones, so free T4 particularly, is low for that period of pregnancy. So TSH is absolutely normal. Pregnant woman doesn't have any symptoms, but still she is on the lower end of the distribution, normal distribution of free T4. And in a series of studies I'm going to show you shortly from the Generation Neuro study, we found that this particular condition can also have impact on child neurodevelopment. So what happens in pregnancy is that, so in a non-pregnant person, we measure TSH usually to screen for thyroid function, because TSH is a good reflection of how the thyroid axis is working. But in early gestation, we have a surge of HCG because of pregnancy, and you see that how HCG can mimic the TSH, and that's why TSH might not be a good measure of how the axis works in around a certain period of pregnancy, around the first 10-15 weeks of gestation. So in a series of studies, we looked at maternal thyroid insufficiency, so hypothyroxidemia, the condition that thyroid hormones are low for that period of pregnancy, but otherwise completely considered normal in a non-pregnant person in relation to child poor neurodevelopmental outcome. And we use data from Generation Neuro, so you've heard a lot so far about that cohort. So I tell you more who are we talking about. So it's a population-based birth cohort in Rotterdam, the Netherlands. This is the city of Rotterdam, which is very modern, not what you have in mind from a Dutch city. So recruitment happened between 2002 and 2006, more than 9,000 pregnant women, most of them in early pregnancy, were recruited into the study. And as we speak, families are still coming to the center for the follow-up of their children. They're in their 18s now. And at different stages of life, children underwent a neuropsychological assessment and also brain magnetic resonance imaging, MRI, that was used for the analysis that I'm going to show you shortly. So in Generation R, another factor, in addition to all this, repeated evaluation of children's behavior, cognition, language development, because the cohort recruited pregnant women so early in pregnancy, we were able to use biospecimen collected in early pregnancy and measure thyroid parameters in these women. So for more than 5,000 women, we had this data in early pregnancy. So I start with showing some results from association of mild thyroid hormone insufficiency and child autistic traits in Generation R at 6 years. So we found that, so as you see in this figure, children who were exposed to mild thyroid hormone insufficiency, so the red groups, they had higher autistic symptoms. So this is not diagnosis, it's a symptom level, but it's still higher levels, meaning more problems. And that was present for boys and girls. Another colleague of mine looked at the same study question in more than one European cohort. So I will get back to this point, why looking at different population matters for a question like thyroid. But for now, just look at the three cohorts, the INMA cohort, which is a Spanish cohort, Generation R from the Netherlands, and ALSPAC, which is a British cohort. Except for INMA, that had very small group of participants who really had low thyroid hormone or thyroid insufficiency in pregnancy, the other cohort, Generation R and ALSPAC, shows consistently that exposure to thyroid hormone insufficiency in pregnancy were associated with higher autistic traits in children. So basically, that was a replication of what we reported before. Then we looked at the same study question, this time with child IQ, so intelligence at age 6 years. And we found that children who were exposed to thyroid hormone insufficiency in pregnancy had about 4 IQ less compared to those who were not, which is a very large effect size for, in my opinion. I always think about lead's comparison because it's one of the most well-known neurotoxicant, and we know that exposure to lead can lead to IQ, like 5 IQ score, lost IQ score in children at the population level. So, and replication of these findings in other European cohorts in INMA and ALSPAC from Spain and the UK, again, found the same results. So findings were very consistent with more or less the same effect size. Then we looked at children's ADHD symptoms, and again, we found that exposure to hypothyroxanemia was associated with 7% increase in score, higher score in children at the age of 8 years. So that's you by now, I think I showed you a lot of neuroimaging studies, and that's why I want to also show you these results, that we thought that, okay, we found association between exposure to thyroid hormone insufficiency, but is it because we have traces of those problems in the brain? And in Generation R, we had children came for the brain scan, and we could look at various brain region, total gray volume, other volumetric measures in the white matter, in the gray matter. And this is a busy slide, but in summary, numbers were very similar in those who were exposed to low thyroid hormone insufficiency and control. So basically, if we just compared the volumetric measures in two groups, exposed and non-exposed, we did not see very strong difference. But another colleague of mine looked at this across the continuum of the thyroid hormone levels in pregnant women. And you see on the right that how the associations were really U-shaped. Basically, those who were exposed to low or high level had lower total gray matter volume, as you see in this picture. this is an indication that if you look at the as a mean level across without consideration for the shape of this association, you might miss what is already there in terms of brain influences of thyroid hormone insufficiency. So when you talk about thyroid hormone insufficiency, two things come in mind in pregnant women. Is it because of iodine insufficiency, or is it the autoimmune processes that are underlying that? So if you remember, I mentioned that why it was important to replicate the findings related to thyroid insufficiency in Spanish, in the Netherlands, or in the British cohort. This is a map of iodine status around the world. And you see that in the Netherlands, I don't know if you see my cursor here. Now maybe. So the Netherlands is a small gray country up in Northern Europe that is really, that has population there, they have adequate iodine intake. This is as opposed to the UK and Spain that are known for thyroid, for iodine insufficiency in women's intake. So to see that if the iodine intake of women in pregnancy is really contributing to what we see in relation to thyroid insufficiency and child neurodevelopment or brain findings, we looked at the UK cohort and also the Dutch cohort. And on the left is what we found in the Dutch cohort in generation R. And we found that if you account for all the covariates, you do not see an association between low iodine concentration in urine, UIC is urinary iodine concentration, and child nonverbal intelligence. The effect size is about 30% increase in low levels of IQ in children, but still it wasn't significant. On the right is the finding from the British cohort, children of 90s or ELSPAC, that they found the same effect size, more or less the same effect size, but in their cohort, the association were significant with low iodine sufficiency, suggesting that the fact that the Dutch cohort was an iodine sufficient population might explain the absence of an association with UIC and IQ in children. We looked at the same two cohorts this time and autoimmunity and in relation to child IQ. Interestingly, the association was different this time. So it was present for the Dutch cohort, but not for the British cohort. Again, back to the underlying status of iodine status in the population. But what about chemicals? So if it's not iodine insufficiency that explains the association between thyroid insufficiency and child neurodevelopment in the Dutch cohort, because that cohort is iodine sufficient, could it be that there are chemicals that they influence the thyroid axis, they disrupt thyroid axis, and that's why they influence brain development of the fetus if, for example, exposures happen during gestation? So we know from several animal studies, experimental studies, and also from epidemiological studies that groups of chemicals that we talked from the beginning of this conversation today, they influence various points on the thyroid axis. And that's the reason that the group of advocates in child health, they put this Project Tender out there, basically really giving warning about this chemical exposure that they influence neurodevelopment. In a few more slides, I'll talk about prenatal phthalate exposure. So in generation now, we looked at phthalates exposure in pregnant women, and we found that exposure in gestation, particularly some groups of phthalate like MEP, MCPP, they were associated with lower nonverbal IQ in children. And this time, interestingly, we looked at brain findings, so something that I showed you in relation to organophosphate pesticides, and we found that the smaller total gray matter volume at age 10 might explain the observed association between higher phthalate exposure and lower IQ in children. So we talked a lot about the sensitive period being the prenatal and gestation, and all the talks today were about the earlier exposure and the DOHAT hypothesis. In the last few slides, I want to emphasize on two new direction. One is about rethinking of sensitive periods of exposure. As we know, brain development continues beyond early childhood. This is the work by Jay Gates' group at NIH, which found that how brain is evolving and developing through the first 20 years of life. And can this period of adolescence can be a period of sensitive period for brain development, particularly because of the balance between development of prefrontal cortex and also the limbic region in that period. The other thing I want to just give you, just mention briefly, is the emerging chemicals. So Dr. Trasande mentioned how we are replacing chemicals by substitutes, and then scientists go and look for health effects of those new replacements. One of them are organophosphate esters or OPEs that are the replacement of flame-retardant, classical flame retardants, PPDEs that are banned. But we know on this graph, you see how the exposure levels are increasing from 2005 to 2015. And these chemicals are very similar to organophosphate pesticides in their chemical exposure, which suggests that they might also be thyroid disruptors. That's something that is shown at least in animal studies. And we also have some studies from humans that show that OPE exposures are associated with thyroid disruption in pregnant women and in their newborns, and it influences pregnancy outcome in women. And only one study found the same association as organophosphate pesticides on child IQ. So that's it for me on influences on brain, and I now ask Leo to tell us a little bit more about the policy implications. I think that's the part that we have been waiting for all this point.
Sure, thank you, Akhgar. Sorry about that. You think this far into the pandemic, you'd understand Zoom muting, but I don't. Anyway, we'll move on to the next slide. I'm going to just talk briefly about the consequences of these exposures, because after all, many of these chemical exposures are the byproduct of companies trying to profit by producing things that we buy, perhaps, or through other people. And ultimately, that economic transaction means that if you're arguing for safer alternatives, some people will say, well, it's too costly to replace chemical X with chemical Y. Where are the health benefits and economic benefits that make the case? And so to put this into context, we did a series of studies back in 2015 and 2016 documenting the costs of endocrine disrupting chemicals in the US and Europe. And recognizing the limitations in what we knew at the time, we used available methods to contextualize the uncertainty of these effects. So we used the best available methods to analyze and grade the epidemiologic and toxicologic literature, so the human and the animal literature. And then we integrated that evidence using the International Intergovernmental Panel on Climate Change's approach to assessing probability of causation. And across 15 exposure outcome associations, we can go to the next slide, we identified probable costs in Europe of over 160 billion euro. That's 1.2% of the gross domestic product in Europe. And that was based on less than 5% of the known endocrine disrupting chemicals, a subset of diseases due to the few chemicals we studied, and a subset of costs due to the few chemicals and the few diseases we're able to study. So at some level, this is shocking already, yet it's an underestimate of an underestimate of an underestimate. And you'll see these costs are driven chiefly by pesticide exposures and their effects on the developing brain, as Akhgar beautifully described. Moving along to the next slide, the story is a little different when we look in the United States. The bad news is the costs are much greater, actually, $340 billion, or 2.3% of the gross domestic product, using similar methods compared to what we did in Europe. But the contributors are different. And the costs of pesticides are lower, and that's because we did the right thing back in the early 90s and required an additional safety factor for pesticides in agriculture through the Food Quality Protection Act, unanimously passed through Congress. Europe, on the other hand, banned flame retardants much earlier than the United States did. We only banned it in 2015 in California by undoing a law called TB 117 that required flame retardants to be added to furniture and other products. So we have a situation in the US compared, as Akhgar described, to any other country in the world, where we have much higher levels of flame retardants toxic to developing brains. So as much as we have lower costs for pesticides, we have much higher costs compared to Europe when it comes to flame retardants. The cost of flame retardants in Europe was on the order of $9 billion a year compared to $240 billion in the United States. So policies predict exposure, exposure contributes to disease, and disease ultimately costs us all. So I'm now going to pivot to what we can do about it at a policy level. So we'll go to the next slide. But before I do that, I want to emphasize the rapidly evolving evidence again. So since 2015, we've seen new reports documenting particular effects. You may have noticed that those costs did not include PFAS, which the literature has exploded about in the past 5 years. And we were not able to include certain outcomes like birth outcomes, breast and prostate cancer in our previous work. So just to give you a little bit of a highlight, we'll go to the next slide. My colleagues and I did a scoping review just to refresh the evidence, and I'm going to buzz pretty quickly through the evidence that we found. We'll go right to the next slide because of time. Metabolic outcomes in particular were new effects that we described. The font I know is small, but PFAS were associated with childhood obesity, impaired glucose tolerance in pregnant women, as well as adult diabetes. We found associations of BPA and BPS with sufficient evidence for probable causal relationships to adult diabetes. And you can see phthalate exposures were also linked to impaired glucose tolerance in pregnancy as well as childhood obesity. So this speaks to the breadth. It's that notion that we only were able to look at 5% of chemicals and a few effects in 2015. And even in a 5-year period of time, this was published early on in the pandemic, we've seen an explosion in that evidence suggesting even more effects. We can go to the next slide. For male reproductive effects, we've seen new evidence linking pesticide exposure to prostate cancer and multiple exposures to reduce semen quality, PFAS, BPA, and BPS, as well as organophosphate pesticides. We'll just go along to the next slide. For female reproductive health, there's newer evidence suggesting effects on polycystic ovarian syndrome, endometriosis due to PFAS, as well as breast cancer due to PFAS. So again, pursuant to the theme that these exposures are affecting all of us, even though the biggest effects that we've described are in kids. We'll go to the next slide. So clearly, we need to do a systematic review and meta-analysis of these associations. We need to assess probability and causation and document the cost. But I just wanted to contextualize how quickly this evidence has changed. So we'll go right along in the next slide and now really focus on what do we have to do about it, because you have to say at some level, when is enough, if you will. We'll go right to the next slide from here. There are safe and simple steps that we can take to limit these exposures. So these are bonus benefits to each of you, things you might be able to do in your own lives to reduce exposure, and then we'll talk about policies to limit these exposures. So going on to the next slide, we know that eating organic can substantially reduce pesticide exposure, and not just in high-income populations of children, but in the next slide, low-income populations as well. An organic diet intervention in a Mexican-American rural community identified decreases in pesticide levels rapidly in days, simply through this dietary intervention. So we'll go to the next slide. Similarly, bisphenols and phthalates have been reduced in exposures in families in a high-income population, and they've been reduced, next slide, in low-income populations as well, in this case through a participatory research intervention looking at labels and what chemicals are in personal care products and cosmetics. So moving along to the next slide, talking about the household environment for a minute, a lot of us have been cooped up due to the pandemic. Household dust accumulates substantial amount of these chemicals. The nonstick chemicals, the brominated flame retardants, and the replacements for the brominated flame retardants called organophosphorus esters. These are data from a study recently done with our colleagues here at NYU, but also at the Harvard School of Public Health, where they did graded levels of an intervention to redo a household and classroom and offices. And what they found was, depending upon the intensity of the intervention with healthier building materials, they found even greater and greater reductions in these chemicals of concern, suggesting potential human health benefits insofar as you live in these environments and are exposed less to these synthetic chemicals. These did not measure chemicals in us as people. That would be the basis for further follow-up research. Next slide. Now, everything I've talked about here is effects that we've taken. We can also talk about avoiding microwaving plastic, avoiding the recycling numbers 3, 6, and 7 in plastic bottles. The recycling number 3 is for phthalates, which we've talked about. 6 is for styrene, a known carcinogen, and 7 includes the bisphenols we've talked about. And avoid machine dishwashing plastic is another example. But we can also talk about policy action, which is really the most important and quickest way of doing this. Now, when you compare the US and Europe, I've already alluded to this, there are some significant divergences. And again, they drive the kinds of differences in exposures we've talked about. Now, there's been some progress since even this slide was put together. On the US side, we've finally seen an effort eventually now with the EPA banning chlorpyrifos, one of the organophosphate pesticides. But that took, as you can see, a 20-year process to get to that point, whereas in the EU, next slide, we've seen much more straightforward action because of a focus on hazard-based interventions. That is, you don't need, in the US, we typically take a risk approach, which considers the exposure, its effect, and what level it has effects at. In the European mindset, when it comes to pesticides and biocides, the new law requires that if at any level there's an effect, you can't allow it for use. And that's led to an earlier ban of chlorpyrifos in Europe compared to the United States. And that's going to be a theme of this final part of the presentation, that we really need to move to a hazard-based mindset, especially when you can't extrapolate from high-dose exposures to low-dose exposures and their effects in humans. Next slide. When it comes to BPA, the story is not that good either for the United States. We had a large investment in a multi-part of the federal government initiative called Clarity to assess the study, to assess the effects of BPA, and even despite ongoing disagreement, even despite efforts to try to concord the Food and Drug Administration's own evaluations of BPA vis-a-vis the academic evaluations of BPA, there still is this divergence where the Food and Drug Administration cannot accept the fact that there are effects at low levels of exposure that are consistently identified in academic studies. And even when they've tried to agree on methods, they haven't been able to agree on the potential effects. Whereas in Europe, the assumption has been made that there potentially is no level at which BPA is safe, or given the presence of effects in mammary gland tissue and cognitive effects, it can no longer be used in France and other parts of the EU. So again, this is where the hazard-based mindset has led to faster action. Go to the next slide. So what kinds of changes do we need? We need to better test and identify these EDCs. We know so little about these chemicals. We need to evaluate exposures better. We need better regulations, as I've already alluded to, and we need an international agency for research on endocrine disruptors. So we'll just go on to the next slide. I'll try to buzz through these quickly so we have good time for question and answer. So one of the problems that we have in the US and Europe is that we don't capture the entire universe of endocrine disruption. We typically focus on sex hormones and thyroid hormone, whereas there are a host of aspects of the hormonal system that we're yet beginning to unravel. And that means that we need to be more comprehensive in our testing approach. There's a lot of progress on this front, but there's a long way we need to go. It's going to require some financial investment as well. Next slide. There is this notion of doing a faster track to testing these chemicals. It's not as though we need to spend years evaluating each of the 80,000 chemicals in the environment. We can use high throughput screening methods to sift out the bad actors on an early basis and then continuously evaluate in a more in-depth way the ones that are potentially on the margins, or potentially identified to be fine based on the tier 1 threshold. And in this regard, there's some rapid flow through human analog systems like zebrafish that can be of great potential in evaluating these effects quickly. Next slide. In terms of evaluating exposure, one thing we haven't talked about is developing countries in particular, and there's very little data about these exposures there, even though they're likely to be the highest producers and users of chemicals by 2030, according to OECD. And disclosure of these ingredients there especially is crucial, and it's, I would argue, a right that they should know about the exposures that they're experiencing in these daily lives. It's important and urgent to focus there because many of these countries have relatively modest environmental protection entities or agencies for various resource and other reasons. We'll go to the next slide. I've already alluded to this notion that we really need to shift to a hazard-based paradigm when it comes to policy. Particularly still in the United States with the EPA and FDA, many of the laws require a evaluation of risk, which posits that you can find a safe level of exposure, but consistently across the literature, we've realized that the dose is not the only thing that makes the poison, and it's actually problematic to identify safe levels a priori. The other problem is that there are long latencies of exposure to disease, particularly if you're using human studies to evaluate effects. Next slide. There are precedents for hazard-based assessments. In Europe, carcinogens already have that mindset. Persistent bioaccumulative and toxic chemicals are similarly considered based without regard to the level of exposure. They're just banned, and EDCs are now on that list. There are a lot of oversimplifications of risk versus hazard out there, which I could argue very cogently are potential disinformation methods. There are a lot of incentives at play to keep the current mindset of risk. Next slide. There are other aspects that can support a hazard-based paradigm. We've talked about the two-tier testing paradigm. There are agreed upon, including with industry, criteria for identifying what is an EDC. So there's actually a lot of place for agreement and ability to move forward. We'll go right to the next slide. And I'll just close by saying that we're in a similar place as we were with carcinogens 50 years ago, where in the 60s we did not really have an agency to deal with carcinogens, and the UN came up with an International Agency for Research on Cancer, an independent entity that would integrate strands of evidence and really come up with probable, possible, or likely carcinogenicity. And it doesn't make policy recommendations, but people listen to the UN and these evaluations with keen ears. Next slide. There are these key characteristics already in play, and this would be very supportive for the ongoing process that I alluded to with the UN for chemicals, called the Strategic Alliance for International Chemicals Management. We'll go right to the next slide. So just to summarize, there's this explosion in evidence that we've alluded to throughout the presentation that document the effects of EDCs on a variety of organ systems, with stronger and stronger evidence as we go along. We'll go right to the next slide here and close. So we need a consensus on what are EDCs. We chiefly have that. We need better methods to evaluate them. We need global programs, because this is a global public health threat. We need better information about what's in these chemicals to start with. There's, in the US, for example, a fragrance loophole that allows trade secrets to stay trade secrets. And we need better data on the health effects of these chemicals across the world. But the reality is we need to boil it down to a hazard-based assessment model that bans the bad actors, even if we don't have perfect evidence for effects. And ideally that would come through the international agency that I alluded to for research on EDCs. So I thank you for your patience. I may need to step off this call before the full Q&A is done, but Akhgar will, I'm sure, ably handle this as needed. And I'm happy to, along with Akhgar, correspond with you offline. Thanks again for the opportunity.
Thank you. Thank you so much, Dr. Trasande and Dr. Ghassabian for an outstanding presentation. I certainly learned a lot during the past hour. And I hope that the audience learned a lot as well. So if you have any questions, you can please add them to the chat and I will read them in the order in which they have been received. Alrighty, so I have one question from Pamela Williams. Thank you so much for your question. And she asked, how can consumers know what products to avoid in a simple list?
So I think the takeaway here is that they're safe and simple steps we can all take to reduce our exposure, and it doesn't require a PhD or have to break the bank. So we've talked about eating organic, we've talked about not microwaving or machine dishwashing plastic, we've talked about the recycling numbers. Sometimes on the label, it can get a little scary. The good news is for personal care products and cosmetics, EWG, Environmental Working Group, has a Skin Deep app that can be very helpful to grade these kinds of things. If you were looking for 2 words on a label in personal care products and cosmetics, it's going to be phthalates, PHTH, or anything with the catch-all fragrance is really hard to understand what's in there. And so, you know, that's a quick and dirty 60-second elevator pitch.
Thank you. I also have a follow-up question on that. Is there a difference in the quality of products that you see being sold in low income areas and higher income areas? So I know that lower income areas are heavily saturated with, you know, Dollar General, Dollar Tree, and all that stuff, and people will go there to buy, you know, baby products or anything like that sort. Whereas higher income areas or middle income areas will have Targets, Walmarts, or any other type of stores. So is there a difference in the quality of products that you see in these 2 different areas?
Well, just on the theme of environmental health disparities, which we did not give justice in this discussion due to time, you know, the reality here is A, these exposures are greater in low-income communities and communities of color. B, we know their products are marketed to those communities and that these exposures thereby contribute to increases in disease and disability that ultimately drive disparities. So the loop is connected, unfortunately, in a way that really speaks to environmental racism at the core. You know, it's been best described for hair products and food packaging in particular, but that's just scratching the surface of a broader problem that's there. You know, the food desert problem in some ways is actually also an environmental chemical problem from the food packaging perspective.
Interesting. Thank you. We have another question from Michelle Chiesa. Have many of these chemicals, phthalates, been found in breast milk?
The answer is yes, as Kara's pointing out, but breast is still best. The benefits of breastfeeding outweigh hazards of the chemicals found. So really the focus should be on policy and preventing these exposures in the moms themselves.
Thank you.
And as I said, I apologize, we have to transition off, but Akhgar can take it from here. Thank you all.
Thank you.
Thanks, Leo.
Thank you.
Are there any other questions? Oh, I see one. You have to scroll up a little bit. So another question is, what is the role of public health, specifically maternal and child health, in reducing exposure? Can public health campaigns to end the use of bisphenols in bottles and cups, the use of flame retardants in car seats and cribs, mattresses, etc.?
So that's just a great question, and I think all of us we talked about the individual, you know, responsibilities we have. That's probably the small part of it. The greater part of it is the advocacy we can do by, first of all, by informing and increasing the knowledge about this health effect, and second, really act as an advocate and talking about those requests. So something that we see a lot at policy level as in EU is because of the demand and request from advocacy group that are asking their policymakers to really think about human health. And I think we can do the same thing in the United States, and that's what the role of a public health expert come into picture. We endocrinologists, environmental health scientists, they provide data that these are the health hazards of these exposures, and then it's up to public health expert to advocate about, you know, how we can really protect especially children from the health effects of these chemicals.
Thank you. And a follow-up question to that would be, how would health departments be educating their communities about these exposures, and know that safer alternatives are often out of reach due to cost and accessibility?
Yeah, that's a good point. It is absolutely true that even though that is getting that's also being addressed, as we see more and more that, you know, it's not that organic food is just really out of reach. It's getting more and more available. It's becoming like the most, you know, commonly seen trend in many locations, but it's still environmental justice is a problem in this country. And what we can do in terms of in informing about, you know, the health effect is, again, it comes back to the policy, I think. And if people know about their rights, and if, you know, if that's, they can do something about it, and then they can ask for some policy changes. And then it's I always think that it's not really the role of the consumer to look for that packaging to find out what I should or I should not use, but as a consumer in this country, I should be able to trust what is offered to me that is healthy and not really impactful my health. So, and that's something that we could all ask for, that it is a right to have access to food, food packaging, and all other consumer products that are not really impactful on our health.
I agree. So switching gears a little bit, I had a question about the organophosphate pesticides. So we know that it can have an effect on children's IQs. So what are the measures being taken today to reduce the use of these pesticides?
Yeah, Leo mentioned that, and he's talked about the act that was really, like, in the United States, it's FDA and other governmental organization that they are really acting to reduce exposure, and in agricultural level and also in domestic household level. And it's one of the success examples in the United States that OPA pesticides is exposure is much lower than many other countries, even in Europe, that usually they have better regulations of chemicals. So that's a success story. But also there are that's a policy level, and then we also know that, you know, there are things that we can do at the individual level. For example, you know, it's not necessarily purchasing an organic product, but also washing the products before use, or, you know, peeling produces when, you know, you can. If you're talking about something like cucumber or eggplant, it's, you know, just peeling apple, the same is another way of reducing exposure if we do not have access to organic products. That's really at the individual level what we can do. But obviously at the policy level, this you know, we have these talks, we talk about the health effects of chlorpyrifos as the example, the data that comes from New York after a better regulation of use in the household at the household level was a good example for many other policymakers, that if we put a policy in place that reduce exposure, you see the benefit in children in the coming year. So that's one of the success, I think, stories in the US.
That's great. And another question is, can consumers or people of the population be 100% trusting of these agencies and companies in the exposure level that they tell is safe to these consumers?
I think we touched base a little bit about the safety level. It's I think in the world of chemical, you always want to take the approach of like hazard approach in consideration, and not really thinking about the safe level, because we know more and more about chemicals that basically we do not have really safe levels, especially when it comes to vulnerable population like children, pregnant women, those with some underlying condition. So I would argue that we should not really go for the safe level, but rather on safety of those exposures. And you asked me about the trust. I think that's why each of us, we are an advocate about, you know, the health effect of these chemicals, and when it comes to food packaging, when it comes to clean water, when it comes about clean air, is always when, you know, as individuals, we know the right, we ask about you know, what about that from people in charge of those policy, then you know, that's how you build the trust, because we know about the health, and by increasing the knowledge, we know how to make our policymakers accountable of what, you know, what they're doing and what kind of policy they're putting into effect. So I think for the first, we have to be informed about those harmful effects. We have to be informed about how we can do better, and then we can ask for it. And I think that's how you build the trust.
Thank you. And also, do you have any tips for MCH professionals who are working in the public?
Oh, I don't know. It's a very hard question. I don't know what you had in mind in terms of tip about like reducing exposure, or what resources we can use to get information. I think the National Toxicology Program has CDC, EPA. These are really valuable sources for people to get information about chemicals. If we don't know about a group of chemicals, we can always search on EPA website, on NTP's website. They share very, very good, clear information, set of information on what are these chemicals, how they can influence our health, and what each of those organizations are doing to reduce exposure level and reduce the harmful effect. I think my tip is to stay informed and use these resources that are available to all of us. We don't need to go and search on PubMed for every question we have. Sometimes this is done by expert for us already, who put this in a simpler question. Not everyone should have expertise in toxicology, for example, to know what is, you know, the harmful chemical. We can rely on those who have already did those type of research, and they put together, you know, documentation for us to use as resource.
Thank you.
I hope it was helpful.
Yes, it was. Thank you. Are there any other questions for Dr. Ghassabian? Let me scroll to make sure I didn't miss anything. So I'm just going to read some of the comments. Pamela stated, I second the need for documentation that is easily understood. I agree with that 100%, because it is sometimes very hard to read and understand literature, especially for students who are getting into the field and they're very new, very fresh in it all. So I agree 100%. A lot of people added different sources that we can look at, Center for Food Safety.org, PubMed articles, and such like that. So if you have the time, I recommend everybody go ahead and look at those different links that were posted in the chat. I'm sure they are good reads. But if we don't have any more questions, I think that wraps up our time with Dr.
Thank you
Ghassabian.
very much. I want to thank you for organizing this session today. It was a great pleasure to be here. And hopefully next time we can meet in person.
Yes, yes, hopefully. 2022, fingers crossed.
Thank you.
Thank you.
Have a good day. Bye.
You too. Bye.